introduction. It's not too late here. It's like 6 p.m., so not that late. Anyways, greetings everyone. My name is Daon, and I am here to talk about my work in progress. Can VM live migration improve job throughput? Evidence from a real-world cluster trace. Here are the contents. So I'll be starting with some background, then how we implemented our simulator, some evaluations from it, and then finally reaching to the conclusion. Again, let's start with some background. And it's not hard to notice how almost everyone started using cloud, even for storage, to developing and testing applications. But recently, some recent resource-heavy workloads like machine learning and big data analytics have been launched in the cloud as well. This naturally made users to create larger VMs using lots of resources. And these cloud providers ultimately came to face a common problem, which is the node underutilization. There seems to be many factors contributing to this, like huge discrepancy between a task or a job's request and its actual usage. So the providers handle the situation with their schedulers and horizontal and vertical scaling, but they couldn't fully solve this. Microsoft Azure showed that 8% of the average node CPU utilization is around 35% and below. For Alibaba Cloud, although the average memory utilization seems high, 75% of average node CPU utilization is 50% and below. And lastly, Google Borg's average node CPU and memory utilization stayed around that 60%, while the maximum allocation could be reached till 200%. So we threw ourselves the question if there are any more ways to improve this underutilization. Then we came to think about this always been there technique of VM live migration. VM live migration isn't something brand new, as it was used for a long time, usually during maintenance of servers. It enables the relocation of a running VM by copying a task volatile state from source to destination. Thus, the total time for VM live migration and the downtime of the VM is the crux. And it's not really used for load balancing due to the heavy repercussions when even the slightest thing goes wrong, the performance degradation could be large. But with the latest and fast network technologies, VM live migration overhead could be reduced to just seconds. And that is how we reached to the question whether if VM live migration can help with the underutilization or not. So we created our simple cluster simulator of our own. The process is straightforward. We first read in the actual task usage distribution from the Google's cluster trace and try to schedule them into a node. Here, the overcommitment factor contributes to how much a node's maximum allocation will be. And according to the maximum allocation of a node, we check if a task request can fit into it. After that, after scheduling a bunch of tasks from this queue, tasks are ran according to their usage distribution. But when a node is overloaded, the resources are allocated proportionally to the task request. Thus, a slowdown occurs for every task in that node. But if migration is actually possible, the node looks to migrate the task or more tasks to another node, and this happens before scheduling more tasks from the queue or running any tasks inside in any of the nodes. And that's pretty much it for the implementation. Implemented as such, we had 20 nodes assumed to be connected by 100 gigabit per second network and tested with real-time submissions of 400,000 tasks. Now, since Google's cluster trace shows the usages in 5-minute intervals, seconds of migration costs were ignored in these evaluations. And with these settings, we wanted to find out how far can overcommitment be pushed, let alone if overcommitment has an effect. Then we wanted to check if VM live migration can help with handling underutilization. So we first tested by changing the overcommitment factor from the multiplier of 1.0 to 3.5 without any VM live migration happening. So shown on the left the mean completion time increases with the overcommitment factor, but as shown on the right, the least mean turnaround time was measured at the overcommitment factor of 2.5. So we've concluded that the overcommitment shouldn't be pushed too far as it can hurt both completion and turnaround time. Next, we texted the same settings, but this time with the VM line migration enabled. Mean completion time shows a similar trend as before, but the mean turnaround time decreases only to a certain degree. Well, it's not shown here, but after the overcommitment of 3.5, there isn't an improvement in performance and only hurts the mean completion time performance. So altogether, compared with the previous slide, there was an improvement in completion time and turnaround time by 5% and 16% respectively at the overcommitment factor of 2.5. And lastly, we wanted to check what would happen under extreme cases where just loads of tasks were queued from the very beginning instead of actual real-time task submissions. So improvements were actually almost the same, 5% and 16%, but as we can see in the heat map shown below, there were some differences in average node and CPU memory utilization over time. And from this short work, our conclusion is that Dreamline migration combined with overcommitment and fast network technology has the potential to improve resource utilization. But this work isn't fully there yet, as our future work will be to set the time scale to seconds and implement more accurate migration cost modeling and policies for precise evaluation, and also, if possible, compare with other existing works such as Cloudsim. Maybe I did the presentation too fast, but that is all for the presentation. Thank you for listening. I'll be glad to take any questions if there is.
Thanks, Daon. That was great. So we are now right on time. So it's perfect for us.
Yes, I actually wanted to tell the first presenter that he has more time, but anyways.
No, that was great. No problem with that. So are there questions in the audience?
Yes, I would like to ask how did you get the number of seconds per live migration?
Number of seconds.
What is it based on?
Excuse me?
Yes, you said that you assume that the live migration takes seconds, and that since your data was in 5-minute intervals, then you neglected these seconds of live migration. So what is it based on?
It isn't actually pretty much based on a reference or anything. We just assumed that, well, the fact that we did reference was the average VM instances from Amazon EC2 was about 64 gig, and using pre-copy policy that with the duplication factor of 1.5, that would mean about 96 gigabytes of transfer. So on a 100 gigabits per second network, we assumed that it would take around 10 seconds is what we concluded to. And even if it took a little more seconds than that, we decided to neglect in the 5-minute cluster traces we've used in this scenario. But we really wanted to do the cost modeling, but it was pretty too hard to do it right now.
Yes, because as far as I know, cloud providers don't do a lot of live migration, if at all.
No.
And I guess that, I mean, they know that live migration can help, and yet they don't do it. And I suspect that they don't do it because it hurts a lot more than just 10 seconds. And there is a lot of variety between different applications. Maybe for some pre-copy would be better, for some maybe post-copy would be better. And it's an opaque object. You don't know as the provider what would be best for the application. You don't know even what would be a good time to maybe right now the machine is not doing anything and you decide to move this one. So it seems to me that there needs to be a differentiation, a characterization of the workloads, and maybe a choice of which machine would be best to migrate. This is something that I would put in the future work. Not just measure, but which is important by itself, but also make a differentiation between different tasks.
Yes, definitely. That's one of the things we have to do, because we've simplified the question a lot here in this work in progress. Definitely, as you said, there's policies to consider. There's numerous other policies to consider. There's placements to consider. You're definitely right on that. We are working towards that. First of all, we're kind of stuck on where the trace is. Even Microsoft, Alibaba, or Google, they're all based on 5-minute averages of their distribution, and we're trying to spread that into seconds.
Actually, I can help you there. We had a paper on that 2 years ago, I think, where we enhanced this 5-minute duration using additional data, like the maximum, the average, and the minimum. We spread it into single second data using beta functions. So I can send you a reference on that.
That would be a great help. But yes, as I was saying, we're kind of stuck on that part, trying to recreate the trace and do a better evaluation on multiple aspects.
Okay, thank you.
That's great.
Thanks for the great question.
Ignite collaborations.
Maybe.
And so are there other questions? A short one before we move on to the next talk. No? So okay, so thank you, Daon, for your talk. And
thank you, everyone.
Thanks. And we can move to the third talk, which is entitled Last Mile Delivery by Drone, a Techno-Economic Approach.
Hello? Bruno, maybe change the recording? Maybe change the recording before you start?
Yep, I was not recording, so.
Ah, okay.
Someone was, but I was not.
No, there is a record. We're being recorded right now. You are recording, as far as I know. So you need to stop and start.
Yeah. So